Here we are with Learning Target 3.1, so I can interpret differences in the shape, center, and spread of two or more data sets. Okay, so notice here we've got data set 1, 1 and 2, age at first job, so we're comparing these two. And that's kind of true as we go down. Okay, we've got these different data sets that we are comparing. And we're just trying to interpret the differences in their shape, center, and spread. Now, when we talk about shape, okay, remember we're talking about what is the mode. Is it unimodal? Okay, and let's just jump into some examples. Okay, question number 1. I like to kind of draw that shape like that. That has one mode, so it's unimodal. Okay. Also, we try to see if it's skewed or a normal distribution. Okay, a skewed distribution is when all the data is in one side. Okay, so it would look like this, skewed to the left or skewed to the right. Or if it's like this one, this is what we call a normal distribution. Okay, so on the shape, that's what we're looking at. So data set 2, okay, see how it kind of goes like that? This one we'd actually call bimodal. Even though that's not as high as that, because it's further away, it kind of causes those two humps. We call that bimodal. But it's still kind of a normal distribution. Okay, it's not really skewed to one side or the other. Though because of this, okay, you could argue it's a little skewed to the right, but we really wouldn't because there's only that one piece of data. Okay, so that's what we do when we deal with the shape. Now the center we're looking at the mean and the median. Okay, now in this we're just kind of interpreting, seeing what's different or the same between the two. So we don't really have to calculate it, though we could in these cases. Okay, so if we were to calculate the median, we would eliminate a high and a low, and we'd find it in between. So right here is where our median would be. Now our mean, because of this piece of data right here and these big pieces right here, our mean is actually going to be pulled up higher than the median. Okay, whereas this one, because it's more of that normal, a lot more normal than this number 2 was, okay, our median and our mean are going to be pretty similar. So our median's right here at 14. Our mean might be slightly above, but it's going to be pretty close to that same one. Okay, so for the shape, center, and spread, we look at the mean and the median. So definitely data set 1 has a lower mean and a lower median than data set 2 does. Okay, so center and spread, that's what we're dealing with, or center. Now with spread, when we talk about the spread is the variability. Okay, so this only goes from 12 to 17, whereas this one goes 12 to 21. So this one has a lower variability than data set 2, which is going to have a high variability. Okay, because it is higher. Also, we talk about outliers. It looks like this guy clear out here could be an outlier. Okay, now we could double check that if we want, but we're just kind of looking at it to interpret, not really getting too crazy with it. So we kind of just list those and then just come to kind of see how they are different in those, the shape, the center, and the spread. Okay, so let's look at data set, or question 3 and 4, I should say. Okay, so looking at 3, okay, we kind of got this shape going on a little bit. Okay, 4 has it even a little bit more. I would say maybe is slightly skewed to the right, and definitely unimodal. Okay, whereas 3 is a little, I wouldn't call it necessarily normal distribution, but it's more normal than number 4 is. Okay, so we could just put that more normal, and definitely unimodal, so they share that aspect in that they are unimodal. Okay, so the center, okay, again, on a dot plot, it's pretty easy to find there's our median here at 2, okay? And our mean is going to be pretty similar, okay, in this case, because there's so many 2s, and not of these few slightly higher ones might adjust it a little bit, so it'd probably be a little bit higher for your mean, okay? Whereas on this one, it's probably going to have a higher mean because you've got a lot more 4s and you've got this 6 clear out here, which most likely is going to be an outlier, which again, that's more with the spread, right? That outlier. And they about have the same variability. This one on the left, data set 1, might have a slightly higher variability, whereas number 4 might have a low variability. Okay, and definitely, well, most likely no outlier. 5 could possibly be an outlier, but it's not really looking like it would be one to me. Okay, so again, if we found the median, still, so it has the same median, but because we've got some that are slightly higher up here, it's going to pull our mean up higher, you know, probably closer to that than it would for the other one. And we can actually, let's actually test that out for this one, okay? So let me clear these. Let's actually find the mean to see, remember we use X bar to identify mean, to see exactly what we've got. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So 7 times 2 is 14. Then 6, 16, and 6. 14 and 16 make 30. 6 and 6 would be 36, 42. So that would be 45. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, so we get 45 divided by 17. Which would be about 2.647. Okay, then in this case we've got 3 again. 1, 2, 3, 4, 5, 6, 7, 8, so that'd be 16. 1, 2, 3, 4, that'd be 12. 1, 4, and 1, 5. So those would be 8, and 12 would be 20. That would be 20, so we'd end up with 40 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 in this case, again. So 40 divided by 17, we get 2.35, so basically 2.4, okay? So we can see, even though they both had the same median, this one, because of these numbers, pulled it up slightly higher than this one did, okay? All right. And we can just keep looking at these just like it. Okay, now if we look at these ones definitely have a higher variability, don't they, right off the bat? Okay, this one's going from 36 to 60, because they're counting by, or they count by ones, so 59, 37. This one 38 to 57. So between the two, they have the same variability. But if we look at these other ones, definitely different variability, but it's a different data set. So they have about the same variability, right? Which I'd probably say is pretty high, okay, especially with test scores. Generally, lower test scores like this, this is an interesting test. This must not be percent, but just score out of something. So I'd say that's a pretty high variability that we've got. And because of that high variability, it's harder to have outliers, so I doubt there's any outliers on those. Okay, so that's our spread. If we look at them, okay, they kind of look pretty uniform, okay? They're not a normal distribution. They're not forming that curve. I would call their shape uniform on both of these, okay? Which you could argue they're 1, 2, 3, 4 multimodal, both of them. But that uniform kind of almost makes it like there's not enough, not one or two that stick out. But we could call them multimodal, okay? Now, for the median, right, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1 and 1, 1 and 1. So our median would be 49. It's pretty spread out. evenly, so I'd say that's pretty close to what our mean is going to be as well. Okay, which is going to be pretty similar with this one, where it does have a slightly higher median, but again, that mean is going to be pretty similar to it because of the way it's spread out. Okay, so that's kind of what we're talking about on that one. Okay, though this mean could get pulled down a little bit as well because of the way the data is. Maybe that'd be another useful one to look at. So if we calculate the medians, okay, let's see what we get, or the means. So this top one we have a 48.2, bottom one 48.5, so pretty similar means, and they're pulled slightly down from the median because these are a little bit more spread out than the upper end is, so it kind of pulls it down. Okay. All right, 7 and 8. So again, pretty uniform here on its shape. Okay, multimodal again. This one is unimodal, but it's still pretty uniform. I mean, there's a slight curvature to it. Okay, and maybe on this one we could even argue that that's a little more skewed to the right. Okay, I think we could say that. So let's call it skewed to right. Okay. Then, thinking about that mean and that median, if we found the median, we would find that it's right in between here. Okay. And that mean is going to be pretty similar. Probably the mean is going to be pulled a little bit because of these guys being stretched out a little more, kind of like how this pulled it down. Okay. So our median would be there, and our mean is probably going to be pulled up slightly higher, not a ton, but slightly higher. Okay, so then we look at the median here, and we get it at 30, so a higher mean, or median, than the other one. Okay, and because it's pretty uniform, though, this one's pretty far off, it's probably going to pull our mean down a little bit. Okay, not a ton, but just a little bit from our mean. Now, if something's exactly a normal distribution, an exact curve like this, your mean and your median end up being the exact same. All right, so there's just looking kind of at dot plots, kind of how we can interpret those. So now let's take a look at histograms. Okay, so these ones we're actually going to have to create the histogram. So what I'm going to do is first I'm going to show you, 11 and 12. We'll do those ones by hand, and then we'll use the calculator to do 10 and 9, because there's some cool things I want to show you with how you can compare the calculators. Okay, so we'll do calculators with those ones after we've got this other one's done. Okay, so for a histogram, we need to do a frequency table, and we want to probably have the same intervals here. Okay, and then we do the frequency of those intervals. Okay, so it looks like our lowest is in the 30s, and we've got 40s and 50s. So maybe that's, and it depends on how many we want to make, but we could do like 30 to 39, 40 to 49, and 50 to 59. Okay, so I'd go, right, 0 to 9, 10 to 20, 30, 40, 50, and 60. And really, if I'm comparing, I want to do the same thing. Same intervals, because it'll help comparing. Okay. So, and then the frequency, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, counting by ones. Oh, and I put that 5 at the wrong place, didn't I? And that's 9. All right, so from 30 to 33, they're in order. So 1, 2, 3, we have 3 of them. We don't really care which exact numbers they are, just that they fit 4 of those, 10 of those. So I'm actually going to have to go up to 10. And again, I could have done it by 5s, and that would have given me different categories to look at. So, it kind of depends. Honestly, with only 3 categories, I kind of like that idea of going maybe by 5s instead. Let's do that instead. So what that would do is mean I'd go 30 to 34, which there's 1. 35 to 39, which there's 2. Then I would go 40 to 44, which there's 1. Then 45 to 49, which there's 3. Then 50 to 54, there's 9. And then 55 to 59, which is there's 1. So then basically I just do 5 by 5s here. Okay. So we'd have the same categories. So 30 to 34 was 0. 35 to 39 was 0. Then 40 to 44, 1, 2, 3, 4, 5, 6. Okay, that's 40 to 44. 45 to 49, 1, 2, 3, 4, 5. 50 to 54, 1, 2, 3, 4, 5. And then 55 to 59, there's 1. Okay? So, also need to do my 5s here. Okay? So then I just, each category, so 30 to 34, we've only got 1, so it goes up to 1. Then 35 to 39 goes up to 2. Okay. Then 40 to 40 is 1 again. Then 45 to 49, there was 3. Then we've got 50 to 59, or 50 to 54, sorry, which there's 9 of them, so that goes clear up to 9. And then finally 1 in this last category. Okay, so there's that one right there. And then we've got this other one, okay, which they started at 40, not till 40, right? So 40 to 45, there was 6 of them. Okay. Then 45 to 49, there was 5. Then there was 5. And then 1. Okay. So, looking at this, our shape definitely skewed to the left, right? The data's all on the right side. Okay. This one's kind of skewed to the left too if we're not counting these. Okay. Now we could also just kind of take it into account just this section of the graph as well. Okay. So this one's definitely unimodal. This one is also unimodal, though not as dramatic as data set 1. Okay. Our median is going to be up here because of this large one right here. Our median and our mean are both going to be up higher, whereas this one's more uniform, so it's going to be just a little to the left. Okay. So pretty close in those means and medians, those centers. Okay. And yeah, I like saying they're skewed. Okay. Now the variability, it doesn't look like there's really any outliers to me, but that variability, definitely we've got a higher variability over here on data set 1 than we do on data set 2. That one I'm going to say is a low variability. Okay, because it's a lot smaller in its range. Okay, so there we go, guys. All right, now let's take a look at 9 and 10, and we'll do the calculator on this one. All right, guys, so we're taking a look here at question number 9 and 10 on the calculator. So again, new document. We should be pros at this now. Data and statistics, but we see no list in the problem here. So what I need to do is I need to go with Control, then Doc, to add lists and spreadsheets. Okay. Then we're going to move up here, and we've got to label it. So we've got two data sets we want, right? Data set 1 and data set 2. So let's see if I can go set 1. Sweet. And set 2. Sometimes it won't allow certain names. Okay. So set 1, we go 6, 6.5, 6.5, 6.75, 7, 7.25, 7.25. Am I bothering you now by continuing to say which number I am typing in, because you're watching and you can see exactly which numbers I'm putting in. Okay, then we do set 2, 5.25, 5.5, and so on. Now these are in order, but it doesn't matter if you put them in order. Okay, you got to remember that on the calculator, that it really doesn't matter. So we put these in. Okay. All right, now I've got my two data sets. So we're going to graph them both and then interpret differences in shape, center, and spread of two or more data sets. But before I did that, yeah, let's do that first actually. Okay, so now it says click to add variable. So I'm going to add whichever one I want to first. Okay, now we actually wanted it in box plot, so I go menu, plot type, box plot. Oh wait, no, histogram. Menu, plot type, histogram. Sorry, getting ahead of myself. There's our histogram. Now, over here it says frequency. I could try to add set 2, but I don't want to. Okay, what I need to do is I need to go menu, and let me see if I remember which one. Okay, plot properties, I want to add an X variable. Okay, so let me do that one again. So menu, plot properties, add X variable. Okay, and I have set 1, so now I add set 2. Okay, and now when I look at this, I can see set 1 and I can see set 2. Okay, so pretty easy to see that set 1 is more skewed to the right, set 2 is more skewed to the left. Okay, so set 1 overall are a lot higher, set 2 are lower. Now their variability is probably pretty similar. Okay, so their variability isn't going to be much different. Set 1 up here is definitely unimodal. Set 2 is unimodal, though with the way it dips down and back up, you could maybe even argue that it's bimodal. Okay, the way it's shaped, whereas this one is more of a up and down. So when we now set 2 is orange, obviously. Okay, I don't know if I can show you there. Okay, I thought you could see my mouse, but apparently you can't unless I do this. There we go. So again, that shape is kind of more normal distribution and unimodal. Okay, whereas down here, you could almost argue that it's bimodal because it dips down and then back up a little bit. Okay, let's see. What else we need to talk about? The variability we already did, about the same. Doesn't look like there's really any outliers there. Okay, the center, the mean, and the median. Okay, now looking at this data, because it's pretty normal, the median and the mean are going to be about center. Okay, down here, again, it has a fairly normal, so again, center. But probably both are going to be less. Now, we can double check that, right? If we go here to that tab, I can hit menu and statistics number 4, stat calculations, 1 variable statistics, except this time I'm dealing with 2 lists. So I can hit delete and type in 2. Then I hit OK. Now I tell it what my list is going to be. So the first list, we'll make that set 1. Thought I clicked on that. So we'll make it set 1. Then the second list will be set 2. Okay. I just make sure they're not in the same column that I have data in. Hit OK, and then I press over, and I can see, okay, this one is set 2 and set 1 is first. Okay, so then remember that's our mean. So as we can see, set 1 has a higher mean than set 2, which is what we suspected. We go down to the median, and that's the same as well. Okay, based off the way that data looks, that's what we can tell. And then we would just graph that, right? Graph both those sets on their paper, and then describe each of those as we already did. So now let's move on. Okay, so now let's do a box and whisker, just a box plot on these ones. So what we're going to do here is kind of the same thing. Okay, we're going to take 2 of these and we're going to do on the calculator. And I'm going to do 15 and 16 on the calculator, and we'll show you a cool way that we can use the calculator for those ones. But let's take a look at these ones first. First we need to get all that data, that 5-number summary, to draw the box and whisker plots. Okay, but first we probably want to label our number line, and we just stack them. Okay, and I'll show you how to do that. So we've got 5.5 to about 10. So if I go 5, 6, 7, 8, 9, and 10, and I'm going to put the 0.5s there as well, but I'm not going to label them. Okay, so we need our 5-number summary, which we need our low number, our first quartile, our median, our third quartile, and our high number. Okay, so they're in order already. So our low, 5.5, high is 10. Okay, find our median, 1, 2, 3 low, 3 high, 3 high, 3 low, 1 and 1, 1 and 1. So median of 8.5 is our middle number. Then we eliminate until we find in between 7 and 7 is 7. So that's our first quartile. 1, 2, 3, 1, 2, 3. In between 9.5 and 10. So halfway between would be 9.75 would be our third quartile. Okay, now we do need to find our interquartile range to make sure we don't have any outliers. Because if we have an outlier, it's going to kind of adjust how we draw it, especially because the calculator does that for us as well. So we take the third quartile, 9.75, and we subtract the first quartile. So we get 2.75 for our interquartile range. Okay, and that's another way we can kind of compare with them. So 2.75, we times it by 1.5. That gives me 4.125. So what I do is I take the 7 and I subtract 4.125 from it. So if I go 7 minus 4.125, I get 2.8. My lowest is 5.5, no outlier on the bottom. Then I take my 9.75, add 4.125, I get 13.8, definitely higher than my highest, so no outlier. Okay, so then I just, on data set 1, my low is 5.5, so I draw a bar. My first quartile is 7, another bar. Midpoint, 8.5. Third quartile is 9.75, so it'd be like right there. So then these form my box. And at 10 is my whisker. Connect the whiskers. There's our first part. Okay. Now we do all the same stuff for this data set. So my low is 6. First quartile, median, third quartile, and high. My high is 10 again. Okay, median is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 1, 1, and 1. So it's 8, my median. Okay, cut that in half for my first quartile. 1, 2, 3, 1, 2, 3. It's 8, and that can happen. Then 1, 2, 3, and 1, 2, 3, 8.5. Okay, is my third quartile. So 8.5 minus 8, third quartile minus first quartile, gives me 0.5. Interquartile range. So looking at this right off the bat, that interquartile range is much smaller for data set 2 than 1. So it's going to have a lot lower variability. Okay, low variability, whereas this one has a much higher variability. And we're going to kind of see that as well when we look at the other parts of the data. But our interquartile range is 0.5, so I'm going to times that by 1.5. So 0.5 times 1.5, giving me 0.75. So I take 8.5 and I add 0.75 to it, okay, plus 8.5 gives me my 9.25. So these 10s are actually outliers. So what I do as an outlier is I draw the dot for that outlier at 10. And yes, there's 2 of them, okay. And then what we would normally do is at the next highest, 9.5, that's where I draw the whisker, okay. And I'll show you kind of both ways that it happens. Then I would subtract, what was it, 0.5 times 1.5 is 0.75, okay. So I go 8 minus 0.75, and we get 7.25. So we actually have a bunch of outliers in this one, don't we? Because 7.25 is right here. So really, at 6 and 6.5, I need to draw 2 more. Because it's such a low variability, that's why I'm having those. So then it would be at 8, would be my lowest. 8 would also be my first and third quartile, and 8.5 would be here. So really, it's kind of a weird box and whisker. Now, a lot of times you'll just not worry about the outliers, and your box and whisker would look like that, with those red dots, red as the whiskers, and that would adjust. Actually, if you didn't think about that, those outliers, what you would end up with is something that looked like this. The low, first quartile and median, third quartile, and the high. Yeah, so it would look like that, okay? Which makes the data seem a lot different than it actually is. That's why it's important to understand those outliers, okay? So our medians, right there, right there. Now, this one has more of a uniform, kind of more symmetric, though it is skewed to the left because the data is on the right, okay? So that would be skewed left. But, modes we can't tell. But it is more uniform. Whereas data set number 2 is probably more uniform, just because all that data is about the same, because it's so squished together. Again, low variability with high variability. Outliers, 1, 2, and 3. Okay, no outliers down here. The medians, the center we see right there. The shape we talked about. Now, for the means, because you've got outliers down here and up here, the mean's probably going to be slightly brought down, but not by much. Okay, whereas data set 1, that mean with all the data up here is going to be probably up a little higher. Okay, well, that's kind of how we can compare those when we look at those. And there we go. So now 15 and 16 we're going to take a look at on the calculator. So, and we'll finish it from there. Okay, now we're taking a look at data set 1 and data set 2 of 15 and 16. So this is minutes to run the 5K. So we are going to go to new document, right? Go down to lists and spreadsheets. Okay, we can do that first. It's all right to do that first. And this time we're doing box plots, okay? So just like we did before, let's name this set 1 and set 2, okay? And then we just put our data in. And so just typing it in, okay? Oops, make sure we don't make any mistakes like that. That would really mess up our scores, huh? And what we were talking about. It's always a good idea to double check things, make sure we don't make a mistake. Okay, so there's our first set of data. Then we do our second set. And it doesn't matter if we do it in order. Just showing you I'm doing this one in a different order. I'm going vertical down the page as I look at the numbers instead of horizontal, which they were in order, so if you go horizontally, they stay in order, okay? But doesn't matter because the calculator is designed to be okay with that. Okay, so we've got our 2 sets of data. Now remember, again, we can go and we can hit menu, right? Go down to statistics, number 4, stat calculations, one variable. We've got a list of 2, so we can do 2, hit OK. When we choose set 1 and then set 2, and the D column works great, hit OK, press over, and again we can see the mean there is about, okay, right? We've got the mean for our set 1, right? Set 2. So set 2 has got a bigger mean. Then we check their medians, scrolling down, okay? And their medians are pretty similar too, okay? So set 2 is actually a bigger mean and a slightly smaller median, which is interesting that you see that in this case. So that'll be interesting to look at and see what that looks like together. So, and we hit Control Doc, right? We want to add the data and statistics because we haven't added that one yet. Okay, then we go down to where it says click to add variable right here. Click, and let's do set 1. Okay, now it starts out as a dot plot, right? So we go menu, plot type, and we want a box plot. So there's our box plot. Now we could click and do set 2 instead. We can see it's box plot. Okay, but if we want to do them both together, we choose set 1 or set 2. Then we go menu, plot properties, and then we're going to add a x variable number 5. Okay, and we're going to choose the set we're not looking at right now, and we can see them both right here. Okay, and we can see that the median, right, 31.9. So this one has a higher median but actually a smaller mean, because the majority of the data is more skewed to the right. Okay, so the majority of the data is here, whereas this one's more spread out, has a higher variability, as you can see from the difference in the first and the third quartiles, okay, and the way that boxes are shaped. Okay, we can't really tell if it's what kind of mode it is based off the box plot. We talked about the centers and the spread, and really if I'm looking at this one, I know that because the median is pulled down that there's going to be probably more data or higher data in this set right there. Okay, and we could kind of double check that if we looked at the histogram version or the dot plot version. Okay, it's kind of interesting to compare all those different types, and kind of neat to see them side by side like that. Okay, so that's pretty good, a good way to visualize and see what's going on with your data sets and understand their shape, their center, and their spread.